Hi everyone. Today we are going to start looking at how to solve system algebraically. We looked at solving systems by graphing and we talked about why that wasn't the best method. But today we are going to start looking at some algebraic ways that will be more effective. And so we're actually going to take 3.2 and split it into 2 days. We're going to focus today on substitution. Tomorrow we'll look at elimination. But for substitution, it's important to note that not every system can be solved by graphing, or it's just not the most effective. And so solving by substitution is best used when one or both equations have an isolated variable. So it would be something like y equals 3x plus 2. It could be b equals 1/2 a minus 4. It could be s equals 9 minus 3t. Any of those would be a good candidate for using substitution because we already have a variable isolated. And I'm going to show you why that's the most effective. So when we already have a variable that's isolated, what it means is that I can have two equations, and with the isolated one, I can take what that value of y equals and I can substitute it in for the y in the other equation. Now be careful, it does have to go into the other equation. If I substitute this over here, I'll end up with something really crazy. So I want to make sure that I substitute it into the y of the other equation. In this case, it was because y was already alone. So when I rewrite that first equation after the substitution, I'm going to get 2x plus, and then I'm going to put parentheses, and everything that y equals, it equals negative 2x minus 1, is going to go in here. And then I'm going to put equals 3. So 2x minus 2x is going to, oh, okay, actually back up. So think about like there's a 1 here, and if I distribute that, it's not going to change the value, so I can rewrite this without the parentheses as 2x minus 1. Equals 3. But then when I'm looking on this left side, I've got 2x and minus 2x, which is 0x. And when my x's cancel out, I don't need to write the 0x. I can just write negative 1 equals 3. Now, this is a little weird because our x is gone, but what we should remember from solving equations is that when our x is gone, we look at the statement that we're left with. In this case, negative 1 is equal to 3. And we say, is this a true statement? Is negative 1 equal to 3? No, it's not. So since this one is not true, we would say that this is no solution. If I were to graph this, it would mean that when I graph the first line and then the second line, they're going to be parallel. They're never going to cross. So this one would just be no solution. For this one, this time I have x by itself, and I don't need to have y by itself. We're not trying to graph. It's okay to have x by itself. I'm going to go ahead and put whatever x equals in parentheses, and I'm going to substitute it in to the other equation. So I'm going to get 3 parentheses, because I get to the x, and then y minus 2 minus y equals 6. When I do distributive property, I get 3y minus 6 and then minus y. Remember, I do not distribute that 3 to the negative y because the distribution ends with the parentheses. So since the parentheses here, it separates the 3 and the minus y. And this equals 6. Now, combining my like terms, I would get 2y minus 6 equals 6. Add 6 to both sides, and we get 2y equals 12, and then divide by 2, I get y equals 6. So that's my first piece of the answer. But remember, if they're going to cross, it means that I have to write what is the ordered pair, and I need both the x and the y value. So I'm going to take what I just got for y, and I'm going to put it into either of these two equations. It doesn't matter which one. So I'm going to choose to do x equals 6 minus 2. I just think it's easier to plug the 6 in to this equation. I could plug it into this one, and that's a good way to check your work. X equals 4. My answer is an ordered pair, so I want to write it as an ordered pair. And I would get 4, 6. Now, I know I'm always on you guys to check your work, so if you wanted to check your work, what we could do is plug this ordered pair in for x and y in both equations. 4 equals 6 minus 2. That's a true statement. 3 times 4 minus 6 equals 6. That would give me 12 minus 6 equals 6, and that's true. So that means that this is correct, and this is my answer. When you're checking your work, that ordered pair has to work for both equations. It can't just work for one, it has to work for both. All right, so for this one, it tells me to use substitution, but I don't have a variable isolated yet. So if you're trying to use substitution and you don't have a variable isolated, you're going to have to manipulate the equation so that you get a variable by itself. What I would do here is say, okay, this y right here, it has a negative in front, but it doesn't have any other numbers. So if I don't have to divide by a number that's in front of the y, then that means I'm not going to have a fraction. And that sounds pretty great. Just seems like a little bit less work too. So I'm going to rewrite 2x minus y equals 7. And I'm going to get y by itself. Minus 2x minus 2x. And we get negative y equals negative 2x plus 7. And then I need to get rid of that negative, so I divide everything by negative 1. So I get y equals 2x minus 7. So that's just to rewrite the equation. So now that I have a variable isolated, I can take what y equals and substitute it in here. I get 3x minus 2 times 2x minus 7 equals 10. Distribute that negative 2 to everything. And then combine my like terms. And now to get x by itself, I'm going to subtract 14 to both sides. And then I'm going to divide by negative 1. So I would get x equals negative 4, or no, sorry, positive 4. And then I'm going to substitute in 4 to one of these two equations. And it really doesn't matter. I'm just going to pick the first one. Except instead of x, I'm going to put 4 minus y equals 7. 8 minus y equals 7. Minus 8 minus 8. Negative y equals negative 1. And then I'm going to divide by negative 1, and I get that y equals 1. So my ordered pair is going to be written as xy, so I get 4, 1. Again, I can check my work by plugging in that ordered pair to both equations. I'd get 2 times 4 minus 1 equals 7. Well, this would give me 8 minus 1, and that is 7, so that's a true statement. For the other one, I get 3 times 4 minus 2 times 1 equals 10. So this would give me 12 minus 2, and that's true as well. So hopefully this has been a good review of how to solve using substitution. Again, substitution is best used when you have a variable already isolated, but if we have an example like this one here where no variable is isolated, we can still change it and use it. We just have to do the manipulating the equation first. If you have any questions, please do not hesitate to reach out and let me know.